Good morning, students. Today we'll try to solve the miscellaneous exercise from class 12th mathematics, that is chapter inverse trigonometric function. Let us try to solve the inverse trigonometric functions miscellaneous exercise. Now, inverse trigonometric functions. We'll begin with the miscellaneous exercise we have. So, miscellaneous exercise. Okay, so we have this question. First question is they're asking to find the value of, first case is cos inverse cos 13 pi upon 6. So this is the case we have. We all know that is cos inverse cos x will be x when x belongs to 0 to pi. Okay, but here 13 pi upon 6 does not belong to 0 pi. So what we can do? We can write as cos inverse cos 2 pi plus pi upon 6. Okay, so now we can say 2 pi plus. Okay, so we know in that quadrant cos will be positive. So now we'll say that it will left with cos inverse cos pi upon 6. Okay, so now we can say it will be pi upon 6 because pi upon 6 belongs to the category that's the interval 0 to pi we have. Okay, because pi upon 6 30 and it is included in the 0 to 180 degree. Okay, so that is how we try to find a value. Let us see what the question second says. The second question is tan inverse tan sin pi upon 6. How to solve this? In a very simple way. Tan sin pi by 6, we know tan inverse tan x will be x, where x belongs to minus pi by 2 to pi by 2. But if I see this value is 210, which is more than this 90. So sin pi by 6 does not includes pi upon 2 to pi upon 2. Okay, so what we can do here, we can write that as it is 7 we have. So what we can write here, if I subtract it from which, if I say that it is, so we can write this as it is positive in third quadrant, so we can write is pi plus pi upon 6. So now we can say that it will be tan inverse tan pi upon 6. So we have pi upon 6. Okay, so we have this pi upon 6 which is included in this interval. Okay, so that is our value will be pi upon 6. So that is how we can easily find the values of inverse trigonometric function. Now let us try to solve the third question now. What the third question says. Now the third question is, in this we need to prove Okay, we need to prove. Okay, so in this third question is 2 sine inverse 3 upon 5 is equal to tan inverse 24 upon 7. Okay, let us try to solve this LHS. 2 sine inverse 3 upon 5. Put sine inverse 3 upon 5 is equal to x. Okay, so that what we can write there. So write sine x is equal to 3 upon 5. Now what we can do? In a very simple way, we know that the identity which we have studied in class 10th, that is sin square x plus cos square x is equal to 1. So we'll try to find the cos, that is 1 minus this. So 25 minus 9, 16 upon 25. So 4 upon 5. Okay. So now we know that tan x will be sin x upon cos x. So we'll see about that is 40 sin x 3 upon 5 upon 4 upon 5. So 3 upon 5 into 5 upon 4. Got 3 upon 4. So we can say x is equal to tan inverse 3 upon 4. We have, okay, x, we have taken this x, this, so we will have 2 tan inverse 3 upon 4 is equal to tan inverse 2 into 3 upon 4 upon 1 minus x square, that is 9 upon 16. What happens? 3 upon 2 into 16 minus 7 upon 16, 16 upon 7, 8. So I got tan inverse 24 upon 7. Okay, is equal to RHS. So very simple way, we can easily prove such kind of inverse trigonometric functions. So let us try and go for a fourth question. Now we have the fourth question, that is so what the fourth question says about, let us try to see. They are saying we need to prove sine inverse 8 upon 17 plus sine inverse 3 upon 5 is equal to tan inverse 77 upon 36. Okay, the very simple way, first we can take this as x and y. So sine inverse 8 upon 17 is equal to x. So we can say x sin x is equal to 8 upon 17. What we can do here? Find the value of cos x, that is 1 minus 64 upon 289. So what I got here? 289 minus 64. 289. Okay. So I got here 15 upon 17. So now I got 10 cos x we have. Okay. So now we have 10x. What will be 10x? Sin x upon cos x. So we'll got 8 upon 17 into 17 upon 15. I got 8 upon 15. So I got x is equal to tan inverse 8 upon 15. Okay, now solve this. A very easy way. Put sin inverse 3 upon 5 is equal to y. So sin y is equal to 3 upon 5. Okay, now what we can do here, try to find a cos y, that is 1 minus 25. I'm using here the identity, that is sin square x plus cos square x is equal to 1. So we have given the sin value, so we'll try to find the value of cos square x. Okay, so we have done this. 16 upon 25. So I got 4 upon 5. Okay. So I got this. Now what we can do? We have cos y. Now we can find the tan y. So let's try to find the tan y. So tan y will be sin y upon cos y into 5 upon 4, 3 upon 4. So we got y is equal to tan inverse 3 upon 4. Okay. Now I got value x and y and put here. So what will happen? Well, tan inverse 8 upon 15 plus tan inverse 3 upon 4. Now we'll try to put the formula here. That is tan inverse x upon y, x plus y upon 1 minus xy. Okay. So there is a formula for that. Tan inverse x plus tan inverse y, that is tan inverse x plus y upon 1 minus xy. So what we have here, let's try to put here. So it will be tan inverse, we have, it will be 60, okay, 32 plus 4, 64, 15, 45 upon I have 3, 5, 4, 2, 1 minus 2, 5 minus 2, 3 by 5. So I have this tan inverse 60 into 5 upon 3, 12. So I got tan inverse 77 upon 36 is equal to RHS. Okay. So that is how we can easily solve such kind of numericals. Now let us move further ahead. Now we'll move to fifth question. What we need to prove? Let us see. I hope it's clear to everyone. So very easy miscellaneous exercise we have for the inverse trigonometric functions. So now we have the fifth question. What is the fifth question says? Fifth question says cos inverse 4 upon 5 plus cos inverse 12 upon 3 is equal to cos inverse 33 upon 65. Okay. So let us try to solve in a similar way. We have solved fourth question. We'll take this x and y. So we have cos x is equal to 4 upon 5 and sin x will be 1 minus 16 upon 25. So we'll have 9 upon 25. We'll have 3 upon 5. So now tan x will be sin x upon cos x. That is sin x upon cos x. So what will have 3 upon 5 into 5 upon 4. So I have 3 upon 4. Okay. So now tan x is this. Now try to solve y. If I solve here y, so it will be cos y is equal to 12 upon 13. So sin y will be 1 minus 9. So I have 25 upon 13. 25 upon 169. Okay. So I have here 5 upon 13. So now I have tried to find the tan y. What is tan y? Tan y will be sin upon cos y. 5 upon 13 into 13 upon 12 is equal to 5 upon 12. So we got tan x also, tan y also. Let's take it z. So cos z is equal to 33 upon 65. Now sin z will be, we'll convert this also in RHS, in 10. So now 1 minus 33 into 33. Okay. 1089 upon 65. 25, 32, 30, 39. So I got here 4225 upon, now I got minus 1089. So I will got here 3136. So now I got this. So now 3136 will try to find the square root of 31 and 36. Now a simple way, let us try to solve how, by taking factors. Well, 4 to 5 will have, that is 65, and 3136. Okay, 3136 will, let us try to solve first. Okay, so let's try to find it. Finally, I have found it. The square of 36 will be 2 to the 4 to the 8 not 56. So I got this sin z. Now we'll try to find tan z. It will be sin z upon cos z, 56 upon 65 into 65 upon 33. So it will be 56 upon 33. So we can say this. Now we have got z here, that is tan inverse 56 upon 33. Now we'll try to solve it further. We have this, that is, we can say we have found this, no, this value and this. Now we can say that is tan inverse x plus tan inverse y. Okay, now we have this. We have taken this x, so x is equal to tan inverse. What I got here, tan inverse 3 upon 4. Let us try to put, plus we have tan inverse 5 upon 12. Okay, so now we'll try to put the formula here. Tan inverse x plus tan inverse y will be tan inverse x plus y upon 1 minus xy. Okay, so I have this. So now what I can do here, well, try to solve it. Okay, so we have here tan inverse, the calcium of 12 will be there, and 9 plus 5. Okay, so now I have this upon, I have 1 minus 5 upon 16. 16 minus 5. Okay, so I have tan inverse 12, okay, upon, we'll get here 16 upon 11. So it will be, so we got here tan inverse 56 upon 33, which I have found it this. So that is how we try to solve it. So we have done 5 questions. Now let us try to solve 6th one. Now let's go for the 6th question. We have just solved 5. Let us see what the 6th question says. Now we have this 6th question. Now what is 6th question says? The similar one now they are saying 6th one, now they have cos inverse 12 upon 13 plus sin inverse 3 upon 5 is equal to sin inverse 56 upon 65. Okay. So these are 6 questions we have. Let us try to prove it. How we can prove? Similar, we have to convert them into 10 so that it becomes easier to prove them. So let's begin with LHS. Take this x and y takes z. So now cos x is equal to 12 upon 13. So sin x will be 1 minus 144 upon 169, because here I am using the identity, that is sin square x plus cos square x is equal to 1. So in order to find sin x, we take cos x to RHS. So like we are doing, it will be 25 upon 169, that is 5 upon 13. Now we know the value of tan x will be 5 upon 13 into 13 upon 12. I got this 5 upon 12. Okay. Similarly, we try to find the value of here this what they have given. They have given the sin y is equal to 3 upon 5. So cos y will be 1 minus 9 upon 25. So we'll have 16 upon 25. We have 4 upon 5. Okay, we have this. Now we'll try to find a tan y, that is 3 upon 5 into 5 upon 4. We got 3 upon 4. So we got the tan, that is we got x is equal to tan inverse 5 upon 12 and y is equal to tan inverse 3 upon 4. Now we'll add it. So we'll have tan inverse 5 upon 12 plus we have tan inverse 3 upon 4. Okay, so now we have the formula here. Tan inverse x plus tan inverse y will be tan inverse x plus y upon 1 minus xy. So we'll try to put here tan inverse x upon 1 minus xy. So I got this tan inverse. No, we'll try to solve here. So we'll got tan inverse, if I take the LCM here, okay, so it will become 12, 5 plus 9 upon 1 minus 5 upon 16. No? Similar the question they have given above also. So we'll have tan inverse 14 upon 12 into 16 upon 11. Similarly, it will be there. So we have tan inverse 56 upon 33 I have. Now we'll try to solve this. So now we have to prove it here. That is, now take this z. So sin z will be 56 upon 65. Now cos z will be 1 minus 56 upon 65 whole square under root. So now we have the value here, that is 56 into 56. We have 1 minus 3136 upon we have 65 into 65. Four, 2, 2, 5. If I got this, I will get a 1089 upon I got this 4225. Okay. 1089 I have, because when I subtract this, 1089, no? Okay, so now if I try to find this value, will be 65. Now I need to find 1089. Create tree. So I got 33 here. So I got here 33. Now we'll try to find a tangent, that is sin z upon cos z. So I got 56 upon 65 into 65 upon 33. So I got tan z is equal to 56 upon 33, or I can say z is equal to tan inverse 56 upon 33. Okay, so that is how we able to solve the numerical. Now let us try to solve seventh question. Now we have just solved only 6. Okay, so now we'll try to solve the seventh one. We have just solved 6. Now let us move to the seventh. What the seventh question says. So we have the seventh question, that is, we need to prove that is tan inverse 63 upon 16 is equal to sin inverse 5 upon 13 plus cos inverse 3 upon 5. Okay, so we need to prove it. Tan inverse 63 upon 16 is equal to sin inverse 5 upon 13 plus cos inverse 3 upon 5. Let us try to prove. Take this as x and y. So now we have sin x is equal to 5 upon 13. So cos x will be 1 minus 25 upon 169. So it will be 144 upon 169. So it will have 12 upon 13. Okay, so we have tan x is equal to sin x upon cos x. So 5 upon 13 into 13 upon 12. 5 upon 12. Now, so x will be tan inverse 5 upon 12. Now let us try to find y here. So cos y will be 3 upon 5. So sin y will be 1 minus 9 upon 25. I got 16 upon 25. I got 4 upon 5. So now tan y will be, what will be tan y here? Sin y upon cos y. So we have sin y upon cos y is equal to 4 upon 5 into 5 upon 3. So I got, what is 4 upon 3? So I got tan inverse 4 upon 3 is equal to y. So I got this. Now what I got here? Tan y, tan inverse. Now try to put the value here. So I got tan inverse 5 upon 12 plus tan inverse 4 upon 3. Okay, so we have tan inverse x plus tan inverse y. We'll have, what we'll have here? We'll try to put the formula here, that is x plus tan inverse x plus y. X plus y upon 1 minus xy. So now I have tan inverse here. If I take the LCM, 13 into 12. So I have got 156 here. So now 65 plus 48 upon I have 1 minus 5 upon 9. So it will be, if I add this, upon the 6 into 9 upon 4. Okay, so I got this. Now we have tan inverse. We have here 4 upon 3. No? So it will not difficult for me to take like this. So we'll have 36 10 plus 48. So it will be 63 upon I have 36. Okay, so now I have, right? So now I can solve this. So I got tan inverse 63 upon 16, which is required. Okay, so that is how we try to prove such kind of numericals. Now let us try to solve the 8th question. Now we have just solved 7, so we'll try to solve the 8th question now. What is the 8th question says? 8th question is tan inverse 1 upon 5 plus tan inverse 1 upon 7 plus tan inverse 1 upon 3 plus tan inverse 1 upon 8 is equal to pi upon 4. We need to prove to this. Okay, so it's very simple. We'll try to put the identity, that is tan inverse x plus tan inverse y will be tan inverse x plus y upon 1 minus xy. So we'll put here tan inverse 1 upon 5 plus 1 upon 7, 1 minus 1 upon 5 into 1 upon 7. Similarly here we'll try plus tan inverse 1 upon 3 plus 1 upon 8 upon 1 minus 1 upon 3 into 1 upon 8. So what will I have here? Tan inverse 35 here, 7 plus 5 upon 1 minus 1 upon 35. Okay, so plus tan inverse 24 3 upon 1 minus 24. Let us take it to the another step now, that is 12 upon 35 into 35 upon 34, and here we have tan inverse 11 upon 24 into 24 upon 23. Okay, further, so I got tan inverse 6 upon 17 plus tan inverse 11 upon 23. Again now I have to apply the identity for tan inverse x plus tan inverse y, that is 1 minus tan inverse x 1 minus xy, sorry. So now we'll try to put tan inverse 6 upon 17 plus 11 upon 23 upon 1 minus 6 upon 17 into 11 upon 23. So now I have this. We'll try to put this tan inverse here. I have into 17. So let's multiply it and find 16, 3, 2. So I got 391. So I got a 391. 91 we have, so 23 into 6 then 138 plus 17 into 11, 17 into 11, 7 1 7 1, so I got 787, so I have 187. Okay, upon I have 1 minus 66 upon 17 into 23, that is got 391. Okay, so I got this. So now I got tan inverse. If I do this, now if I multiply, if I subtract this, so what I will got here, 391 minus 66. So finally, what I got here, that is tan inverse 1. So I can say, I can write it 10 pi by 4. So finally, I got my answer, pi upon 4. Okay, so that is how we able to, try to prove. So we have done 8 questions here. Now we'll move to the next one. Now let us try to solve next question. We have just solved only 8. So now we'll try to solve next question we have. That is the next question I have to prove that only that I have, that is we'll take this question as cot inverse 1 plus sin x plus 1 minus sin x upon, I have 1 plus sin x, and we have minus 1 minus sin x we have, and we need to prove it to x upon 2, that is x belongs to 0 to pi upon 4. Okay, so now I have, what can we do? We'll try to solve this first. Take as an LHS, that is cot inverse 1 plus sin x plus 1 minus sin x. We have the root. So what we'll do? We'll rationalize. Okay. Let us try to rationalize it. What I got here? 1 plus sin x plus 1 minus sin x upon, we have 1 plus sin x minus 1 minus sin x plus y. So now we know when we rationalize any number in root, their sign also changes. Now what we will have? Cot inverse. Now a plus b into a plus b, a square plus b square. So we have a plus b into a plus b. So we'll have a plus b whole square. A plus b whole square upon, I got a minus into a plus b, a square minus b square. So I have a square minus b square. Okay, so I have this. So now I have to put this. So I got cot inverse a square plus b square into, you have 2ab, 2 into plus 2 into ab, a into b. Root will not be there, root will cancel out, so we have 1 minus sin x. Now upon, I have 1 plus sin x minus a plus b into a minus a square minus b square minus 1 minus sin x. Okay, so I have this. So now what will happen? Reduced. So I got 2 plus 2 into 1 minus sin square x upon, I have 1 plus sin x minus 1 plus sin x. Okay, so I have cot inverse 2 plus 2 cos square x upon 2 sin x. Okay, so I got this. So 2 will be reduced by here. So let us try to solve this. Cot inverse 1 plus cos square x upon I have sin x. Okay, so now I have this. Now I have this that is inside the root. So now I got cos square x. It will be cos x. Okay, 2 we have reduced, so we have this now, cos x. Okay, so now my next step will be cot inverse. Okay, so now I have 1 plus cos x upon sin x. So we'll write this as, now we have 1 plus cos x, I can write as 2 cos square x by 2 upon sin x, I can write 2 sin x by 2 cos x by 2. We have used a formula, that is sin 2x will be 2 sin x cos x. So if I reduce this by 2, so what will happen? Sin x will be 2 sin x by 2 cos x by 2, and similarly here I have used a formula here, cos 2x, that is 2 cos square x minus 1. So now I will be taking that 1 plus cos 2x is equal to 2 cos square x, but if I divide by 2, so 1 plus cos x will be 2 cos square x by 2. Okay, so that is how I have done this. Now we'll reduce this. So we'll have cot inverse cot x by 2. So I got x by 2, which is required here. Okay, so that is how we find the, we need to prove like this. Okay, now let us try to solve the next question. Now we'll try to solve the next question I have. I have just solved 9 numericals. Now let us try to solve the 10th one I have. That is tan inverse 1 plus x minus 1 minus x upon, we have 1 plus x plus 1 minus x. We have this 1 plus root 1 plus x minus 1 minus x upon 1 plus x plus, we need to prove it to pi by 4 minus, we have this 1 by 2 cos inverse x. Now we have given that x lies between 1 upon minus 1 upon root 2 to 1. Okay, let us try to put this. We have take this LHS. Now put x is equal to cos 2 theta. So I will have 1 plus cos 2 theta minus 1 minus cos 2 theta upon, I have 1 plus cos 2 theta minus 1 minus cos 2 theta under root. So now what will be my next step? That is 1 plus cos 2 theta. We know the formula is, that is 2 cos square theta minus 1, 1 minus 2 sin square theta. So now they have 1 plus cos 2 theta, so it will be 2 cos square theta. 2 cos square theta minus, it will be 2 sin square theta upon 1 plus cos 2 theta. It will be 2 cos square theta minus 2 sin square theta. So we have this. So now we can do like this: root 2 cos theta minus root 2 sin theta upon root 2 cos theta minus root 2 sin theta. Okay. So I have this. So now what we can do here, in a very simple way, take root 2 to common, it will reduce. So we have this, that is tan inverse cos theta minus sin theta upon cos theta, no, wait, this is plus sin theta, because we have taken root 2 common from both numerator and denominator and we have cancelled out. Okay, so now we have this. What we can do is divide numerator and denominator by cos theta. So I will have tan inverse, wait, we'll show again, tan inverse 1 minus tan theta 1 plus tan theta. Okay, so now what we can do here, we'll try to put 1 as 10 pi by 4. So it will be, okay, let's try to solve here. That is tan inverse 10 pi by 4 minus tan theta upon 1 plus tan pi by 4 plus tan theta. So now this is a formula we have, but the formula is tan A minus B. That is, we have tan A minus B will be tan A minus tan B upon 1 minus 1 plus tan A tan B. Okay, so I have the formula here, that is tan A minus B. So now what we'll have, I have only left with this pi by 4 minus theta. Okay, so now what is theta here? I have put x is equal to cos 2 theta. If I divide by 2, I got this. So x by 2 cos inverse is equal to theta. So we'll put here, that is pi by 4 minus cos inverse x upon 2. Okay, so that is how we try to solve such kind of questions. We have divided by 2. So now cos theta is, we have tried to cos 2 theta, so it will be cos inverse x by 2. So that is how we try to prove that numerical. Okay, so like this. So now what we can do here, we can write like this. So we'll get pi by 4 minus half cos inverse x. So that is what we have. Half I can take here, so half will be outside. So now we'll have cos inverse x, that is half cos inverse x. So that's how we try to prove, that is LHS is equal to RHS. Now let us try to solve another one. Now let us try to solve the next question we have. So we have solved 10. Now let us try to solve the 11th. Let's solve 10 questions. Now let us try to solve the 11th one. So we have, that is the 11th question, that is 9 pi upon 8. I have 9 pi upon 8 minus 9 upon 4 Sine inverse 1 upon 3 is equal to 9 upon 4. Sine inverse we have 2 root 2 upon 3. Okay, so we need to prove this. So what we can do here? Now very simple way. Let us try to solve this. LHS we have. Okay, so what we have? LHS 9 pi upon 8 minus 9 upon 4 sine inverse 1 upon 3. Take 9 upon 4 common. So I have pi upon 2 minus sine inverse 1 upon 3. So what I can do? I will write this as cos inverse 1 upon 3. Why? Because we know that sine inverse x plus cos inverse x will be pi upon 2. We have this formula, that is sine inverse x plus cos inverse x is equal to pi by 2. Okay, where x belongs to minus 1 to 1 we have. Okay, so now what we can do here? Put this y. So cos y is equal to 1 upon 3. So sin y will be 1 minus 1 upon 9. So we have 8 upon 9 we have. So 2 root 2 upon 3. Okay, 2 root 2 upon 3. Now what we can do here? That is we have y is equal to sine inverse 2 root 2 upon 3. Put it here this value. So I got 9 upon 4 sine inverse 2 root 2 upon 3. That is equal to RHS. So I have used this identity plus I have used, that is sin square theta plus cos square theta is equal to 1. So in order to find sin, if cos is given, we'll take it to RHS. So that is how we'll try to prove such kind of numericals. Now let us try to solve the next question we have. The very simple way. Now what is given in this, that is 12th question I have, they have given, that is we need to prove tan inverse root x is equal to 1 by 2 cos inverse 1 minus x upon 1 plus x. Okay, now they have given that x belongs to 0 1. So now what we can do here? Try to put x is equal to tan square theta. So we have half cos inverse, will take first RHS. So 1 minus tan square theta upon 1 plus tan square theta. So I have this, that is cos 2 theta. Now the formula of cos 2 theta, that is 1 minus tan square theta upon 1 plus tan square theta in terms of tan. So now we have half into 2 theta, that is theta. So if I take the square root of this, so we'll get root x is equal to tan theta. So root x is equal to tan theta. So we'll have theta, therefore theta is equal to tan inverse root x. So I have done this. Now very simple way, we have proved this is equal to LHS. So that is how we able to solve such kind of numericals. Now we'll move to the next category. In this 13th question we need to solve. Okay, we have just proved 12 questions now. Now in this we need to solve the following equation. Now the question arises, that is we need to solve the following equations. How? Let's move for 13th. We have 13th question here, that is they have given 2 tan inverse cos x is equal to tan inverse 2 cosec x. Okay, this is the question I have. Now what we can take as, we'll try to put a formula here for 2 tan inverse x in terms of tan will be tan inverse 2x. Here x we have cos x upon 1 minus x square cos square x. So I have that cos x. Now what will happen? So we'll have 2 cos x upon 1 minus cos square x is equal to 2 cosec x. So we have cos x upon 1 minus cos square x is equal to cosec x. Okay, so now the next we have, that is cos x upon sin square x. We can write cos x 1 upon sin x. So we have, now we can say that is cos x is equal to sin x, or I can say tan x is equal to 1. So we'll say x is equal to pi upon. Okay, so that's how we try to solve the following equation. We have one more question now, that is 14th, that is tan inverse 1 minus x upon 1 plus x is equal to half of tan inverse x. Now what we can do, put here, we have given the condition also that x is greater than 0. Okay, so we have, now we have what we can do here, we have tan inverse 1 minus x upon 1 plus x is equal to half of tan inverse x. So now what we can put here, we have the similar formula for this, that is tan inverse 1 minus x 1 plus x, that is tan inverse 1 minus tan inverse x. We have that is tan inverse x minus tan inverse y is equal to tan inverse 1 minus x upon 1 plus x. Now we'll say like this, that is of identity we have, that is tan inverse x minus tan inverse y will be tan inverse, what will have, x minus y upon 1 minus xy. Here x is 1 and y is x. So that's how we have used this identity. Now we'll try to solve this here. X, so it will be power 4 and we'll take this that side, so it will be 3 by 2 tan inverse x. So we can say we have pi upon 6 is equal to tan inverse x, or you can say x is equal to tan pi by 6. So tan 30 will be 1 upon root 3. Okay, so that is how we able to solve such kind of equations. Let us move to another one, that is, now we will try to solve the 15th one. Now we have the 15th question now. Now we have the 15th question. What is given? Sin tan inverse x. We have sin tan inverse x, where they have given x is less than 1. So here we need to find its, this is not an equation, we need to sort it out. What we can do is, we can take sin as we can take this tan inverse x is equal to theta. So we'll write sin theta. Okay, so now we can write it as 1 upon cosec theta, or we can write as 1 plus cot square theta, or you can write now x is we can put, we have this 1 plus cot square theta, we can write as it is, we have the identity, so 1 upon 1 tan square theta. So I can write as x is equal to tan theta, so tan square to x square, so we'll have 1 plus 1 upon x square, so I got 1 upon x square plus 1 upon x square as it is, so we'll have x upon 1 plus x square in the root. Okay, so that is how we can find such value. Let us try to solve another question now. What we need to find, let us see now. They have given sine inverse 1 minus x, that is sine inverse 1 minus x minus 2 sine inverse x is equal to pi upon 2. So now we need to find the value of x. How? Let us see. Now what we have, what we can do here, that side we'll take this, so pi by 2 minus sine inverse 1 minus x, so it will be minus 2 sine inverse x is equal to, we have cos inverse 1 minus x. We have given this, and in this we need to find the value of x. Okay, so how? Now we have used one identity, that sine inverse x plus cos inverse x is equal to pi upon 2. If I take this, so we'll have cos inverse x. Here we have this. Okay, so this is we have. Now what we can do here, put sine inverse x is equal to y, so we can say sine y is equal to x, so we can say cos y will be 1 minus x square under root. So what we will say, y is equal to, y will have this cos inverse 1 minus x square. We'll try to put it here, so that we got minus 2 cos inverse 1 minus x square is equal to cos inverse 1 minus x. We have this. So now what we'll do, we'll try to sort it out. We have minus 2 cos inverse 1 minus x square is equal to cos inverse 1 minus x. So now what we can do, we have this, so let us see what we can do. Now what we can do here, put x is equal to sine theta, so that we have minus 2 cos inverse 1 minus sine square theta we have, or you can say as it is x is equal to sine theta, so here we have cos inverse 1 minus x. Now we have minus 2 cos inverse, it will be cos theta we have, or I can say sin y if I take this, so it will be easier for us. So we have, that is, they have given the question, that is a 16th question we are doing. So now what will happen, that is cos theta is equal to cos inverse 1 minus x. So now we have minus 2 theta is equal to cos inverse 1 minus x. Okay, so we have done, so we can take cos minus 2 theta is equal to 1 minus x. Now what we can do further, we can say cos 2 theta is equal to 1 minus sin y. We have taken x as sin y, so we'll put here sin y. I can write as 2 sin square, we have 1 minus 2 sin square y is equal to 1 minus sin y. Okay, so now if I take this, I'll got 1 minus 2 sin square y minus 1 plus sin y is equal to 0. So now I got sin y minus 2 sin square y is equal to 0, or I can take sin y common, so I will have 1 minus 2 sin square y, sin y, sorry, 1 minus sin y is equal to 0. So now here I have two cases. Sin y is equal to 0. So we have y is equal to 0, and in that 1 minus 2 sin y is equal to 0. 1 is equal to 2 sin y. So sin y is equal to half. Okay. So we have sin y is equal to half. Now here we will have y is equal to pi upon 6. So we have two values there, y is equal to 0 and y is equal to pi upon 6. So that is how we try to solve such questions. Okay. So now let us try to solve one more, that is the 17th we have. Let's have a simple question now. I hope it's clear to you. And now we'll try to solve that question, 17th. So I have 17th question in my hand, that is tan inverse x upon y, x upon y minus, we have tan inverse x minus y, x minus y upon x plus y. Okay, so we'll apply the formula here, that is tan inverse x minus tan inverse y will be tan inverse x minus y upon 1 plus x plus y. So we'll have tan inverse, we have this, that is x minus y upon 1 plus this y. So we'll have this identity here, so it is tan inverse x plus y minus x minus y we have into y upon x plus y into y upon x plus y into y plus x minus y into x upon x plus y. So what we'll do here, we'll reduce this. So we have tan inverse x square plus xy minus xy plus y square upon same case here, xy plus y square plus x square minus xy. So we'll have this, that is tan inverse x square plus y square upon x square plus y square. So we'll have tan inverse 1, I can write it as pi upon 4. So in this we need to find the value of this question they have given. So I hope it's clear to everyone. If you have any doubt, you can ask, comment or share, and please also like my channel.